Hello, and welcome back to another edition of Nifty Notions. I'm Jason.
And I'm Andrew. Jason, we live in Sydney, Australia, which is in the temperate zone, not in a tropical zone, but we do suffer from really humid and hot summers.
Yeah, we do.
And one of the interesting things about humidity, we often look at, people often say it's really humid today, it's fairly muggy, and we hear the measures of temperature and relative humidity, typically.
Yes.
Have you ever heard reference to dew point?
I have, and I'm told it's a very accurate measure, but I have no idea what a dew point means in relation to the other things.
Okay. If you want to look at what is comfortable in terms of temperature and humidity, all you need to know is what the dew point is.
Okay.
And it's a fairly static kind of a measure for understanding comfort.
Yeah.
And I'm going to go through that and I'll explain what the range is, where you might find it's comfortable or not. But it is related to temperature and it is related to humidity, or more specifically, relative humidity. But what I want to do is also describe what they are so we get a better understanding of where all this is. So temperature is fairly straightforward. We usually talk about the ambient temperature.
Yes.
You can hold a thermometer in the air and measure the temperature. Strictly speaking, that's called a dry bulb temperature. So
Dry
bulb. So we have dry bulb and wet bulb, and these are how we derive a lot of these other measures.
Okay.
So dry bulb is just simply a thermometer, okay? Measure the ambient air temperature.
Okay, right.
Now wet bulb, usually you'll have these two together. If you want to know what the relative humidity is, what the dew point is, what the temperature is, you're going to have a wet bulb and a dry bulb thermometer. Dry bulb is your standard thermometer, just on its own in the air. And a wet bulb is the same thermometer, same type of thermometer, with a little reservoir of water below and a wick coming from the reservoir and over the bulb holding the mercury in the thermometer. If there's low relative humidity, the moisture will evaporate quickly off the wick, which will actually cool the bulb, which will give you a lower temperature reading right next to a dry bulb thermometer. When it's high humidity, the temperature is going to be closer to the actual temperature. When there's low humidity, the wet bulb temperature will be much lower because of evaporation. Okay?
Yeah.
So we're cooling the bulb by water being evaporated from the wick. So from those two, we can get the relative humidity and the temperature, and we can go to a psychrometric chart, and we can then derive the relative humidity, which tells us for the given temperature how much moisture is in the air.
Okay.
So at a temperature, it can only have so much moisture. That's the relative humidity part. This brings us to dew point, which we can also measure from dry bulb and wet bulb temperature. The dew point and the temperature are two things that work together. So the dew point is a temperature at which we have complete saturation of the air with water, so 100% relative humidity.
Right, yeah.
And this kind of number is an interesting number because we do have ranges where it doesn't matter what the temperature is, what the actual temperature is, if the dew point of that temperature is at a set point, we can feel a certain level of comfort. So what I'm trying to say here is, if the dew point is between 10 degrees and 16 degrees, that is typically comfortable temperature.
Okay.
So we could get a measure of, we could have a combination of temperature and relative humidity, let's say 30 degrees Celsius, and maybe a 100% humidity, and we'd know that that's got a very high dew point. We'd be above, we'd be actually up near the 30 degrees in dew point, which would be intolerable. So our ranges are anything below 10 degrees Celsius is extremely comfortable.
Right.
Between 10 and 16 is regarded as comfortable for everybody.
Okay.
From 16 to 20, it's starting to feel muggy, and above 21, it's unbearable.
Okay.
For most people.
Right.
Okay. So that's that's a given. It doesn't matter what the temperature is. If you have a look at dew point, and often in the apps on your phone these days, you can actually see, usually right next to where it says what the relative humidity is, you get the dew point.
So does it matter, like if I stop looking at temperature and just look at dew point from now on, that will just tell me what I should wear outside and how I'm going to feel? And
it'll tell you how comfortable it is, because I mean, if we have a dew point that's say 10 degrees, we're in the comfort zone, but the actual temperature is 10 degrees. That's pretty cold.
Yeah.
So you're going to have to wear something for it.
Okay.
But it's when you start getting to elevated temperatures that this really comes into play.
Okay.
So you could have 30 degrees, again, I'm going to use 30 degrees, and you could have like a dew point of 5 degrees, which tells you it's very low humidity, but it actually is not an uncomfortable temperature if you're in the shade.
Okay.
Because you're still evaporating.
Yeah.
The moisture, the perspiration is still evaporating and you're cooling down. But if at 30 degrees you're up in the 21, 22, 26 of dew point, it's grossly uncomfortable.
Yeah.
So some of the things where you see weather forecasters saying we're expecting fog or frost tomorrow morning.
Yes.
That's when, let's say we've got in winter, typically you're going to get fog. I mean, you get that in summer too. But winter you're more likely to. You could have a low temperature of say 5 degrees ambient temperature. And they might say the dew point is 5. The dew point will never be higher than the ambient temperature. It's not. It can't be 6 degrees if it's 5. But at that level, you know we're going to have fog, and if it gets cold enough, we're going to have frost. So if the temperature drops below 0 and the dew point is right up there, you're going to have frost.
How does rain affect the dew point? If it's like buckets with rain?
Well, that's sort of up at the high levels of dew point, where dew point is matching up close to the actual temperature, but more so up where the clouds are, rather than where we are.
Okay.
So with a home, if you've ever seen homes that are being built, you see this sort of cardboardy type wrap on the outside. It's a common thing these days.
Yeah, I've seen that.
And that's a weather wrap. That stops humidity and wind passing through it.
Okay.
And what you would match with that with a new building is doors that are perfectly sealed and windows that are perfectly sealed when they're shut. So you have no exchange of air between outside and inside. Now, if it's a small place, that's not a good idea. But for a larger house, that's fine. So what happens, what you can have if you don't have that moisture wrap, humidity from outside can come into the house very easily. And so we could find that if, say, you run an air conditioner at 21 degrees or 22 degrees when it might be 30 degrees outside and inside temperatures 21, 22, it's really difficult to budge the humidity down. You will move it down, but you're bringing the temperature down, which is making it more comfortable. But your dew point is still up. So you could have a dew point of 26 degrees outside and 30 degree actual temperature. And inside you might have 22, but what your dew point is 22 in a highly humid environment because you just can't get rid of that humidity because the house isn't sealed. And that is when you start to get condensation on walls.
Yes.
And you can get mold, especially in summertime.
That's right.
So that's one of those little tricky things where people wonder, hang on, I'm dehumidifying the place by running my air conditioner, but I'm still getting mold. And that's why you're still getting mold. So you need to have a fully sealed house, windows, doors, and a wrap around the house for that to happen.
My house is very old. It's a double brick house. And I notice in summer when the bricks heat, the house is hot.
Yes.
And I can't really control that temperature because I don't have that sort of insulation in the house.
Yeah, and that's one of the things with the older built houses. And they also have a lot of vents between inside, outside.
They do, don't they?
Yeah, built-in little brick vents.
Little grated things.
Yeah, and they'll try and vent. And so you've got no hope of keeping the temperature or the humidity out of the house. Well, they wouldn't do that these days with a modern dwelling.
Interesting.
So that's the relationship there. I've put on the screen the comfort temperatures. So all you got to remember is go for dew point. It's a nice simple system to know if it's comfortable. It's especially so in summertime, wintertime not so much. You got to rug up and you're not worried about perspiration because you just don't get that hot. And I'm going to thank my daughter's friend Alex Cole for recommending this video.
Thanks, Alex.
She had a conversation with my daughter when my daughter was trying to explain to her what this all meant. And she said, your dad should go and put this on a video. So thank you to Alex.
Thank you for that.
That's right.
Andrew. That's been brilliant. And that's it for today for another edition of Nifty Notions. I'm Jason.
I'm Andrew.
See you next time.
Bye.